Hey there, Gregory Carlson here for the math building, and we just used the power rule to find the derivative of a bunch of functions really quickly, and it was really nice. So now let's find some tangent lines. This question asks us to find an equation for the line that is tangent to the curve y equals x to the 3 minus 9x at the point 3, 0. So what is the tangent line at 3, 0 that only touches the graph in one place? Well, to figure that out, first we need to do the derivative. First we need to find dy dx, because that's going to tell us the instantaneous rate of change at every value x on our function. And so luckily that's really easy to do. The derivative of x to the 3 is just 3x squared. And the derivative of 9x is just negative 9. See how easy that was? So this is the slope of the graph at every single point of x to the 3 minus 9x. So let's see what the slope is at the value x equals 3. And to do that, I just plug in 3 in for x. So that'll be 3 times 3 squared minus 9. And 3 squared is 9 times 3 is going to be 27. And so we see that the slope is just going to be 18. So at the point 3, 0, the slope of this line is 18. And now we know the slope, we know a point, and so now we can just use the point slope formula, or y minus y1 equals m times x minus x1. So let's plug in these values. I have y minus 0 from our point. We figured out that our slope was m, was 18, and our x value at the point was x minus 3. And that's it. So let's just clean it up a little bit. Y minus 0 is y. Let's do the distributive property. We'd get 18x minus, and then 18 times 3 is just 54. So that's the equation of the tangent line of the point 3, 0 of this curve. So let's go ahead and look at a sketch of the graph of what that would look like. And so notice that I could kind of factor off an x here and get x squared minus 9. Do you agree with me on that? And then I could factor the difference of squares and get x minus 3, x plus 3. So I can see where the zeros of my graph are going to be located. We're going to have a 0 at 0, a 0 at 3, and a 0 at negative 3. So this is just going to be a rough sketch of the graph, but it should look, the cubic function should look something like this. And again, that's just a rough sketch. That's not exactly correct, but it's pretty close. And so they wanted to know what is the tangent line at this point right here. That point right there is 3, 0. And you can see that we're going to have a pretty steep tangent line right there. That's only touching the graph in one place. And we know what this point will be right here. That point is negative 54. Because that's the y-intercept of our tangent line. And so we see that this tangent line is pretty steep. It has a slope of 18, and it's supposed to be straight, so just imagine it's straight. And you can see that it would cross down here at negative 54. So thanks to our derivative function, it's real easy just combining it with the point slope equation to find the equation of a tangent line. So let's do another example. It says here, for the function, find the points on the graph at which the tangent line is horizontal. Or if none exists, then state that fact. So this is a really, really important one. You see that we have a parabola. So if we think about it, if I have some parabola, whether it's a positive parabola or a negative parabola, just looking at the graph, there's only one candidate of where the tangent line should be horizontal. And that point would be at the vertex. So at the vertex of a parabola, just by looking at it, and we'll talk about more about this later, we see that the only place where the tangent line should be totally flat or horizontal is at the vertex, where it finally finishes turning the corner and starts pointing the other way. So let's do it. Let's find the derivative first. dy dx is going to equal, in this example, 2 times negative 0.03 is negative 0.06. And that becomes x, right? Because we dropped the power from 2 to 1. The derivative of the second term is just going to be negative 0.9. And the derivative of this constant term is just 0. So we're actually done. Here's the derivative of this. The 2 came in front, so it's negative 0.06x minus 0.9. Now, if we're trying to find out where the derivative is flat, or where the horizontal line would be flat, that means we would plug in a 0 for the derivative. Okay? And so now we just need to solve this equation. 0 equals negative 0.06x minus 0.9. And now we just solved that equation. So let's do it. Let's add 0.9 on both sides. Cancel. And we get 0 equals negative 0.06x. And in fact, that should be 0.9, so apologies for that. And finally, we just divide by negative 0.06. So we see that the x value where we're going to have a slope of 0, a horizontal tangent line, is 0.9 divided by negative 0.06. Whoops. 0.9 divided by 0.06. So in this case, at the value x equals 15, the tangent line is going to be 0, has a slope of 0, and also that's where the vertex is. And in fact, that should be a negative number because we were dividing a positive divided by a negative, so that's a negative number right there. So let's pause for a second and connect a piece of college algebra. Remember in the algebra building, in the algebra 2 building, that I told you that if you have a parabola of the form f of x is equal to ax squared plus bx plus c, I told you that magically the x part of the vertex is this magic number negative b over 2a. Do you remember that? I'll put a link to that video in the description. So I told you that's just going to be the x part of the parabola. But now we can see why that is. Because if we take the derivative of this, we see that the derivative of this function is going to be 2ax to the 1 plus b. So the derivative of ax squared is 2ax, the derivative of bx is b, and the derivative of c just goes away because it's a constant. And so the vertex of a parabola is going to happen when we have a horizontal tangent line. And so if I plug in a 0 right here, I get 0 equals 2ax plus b. And if we just solve this for x, subtract b on both sides, you get negative b is equal to 2ax, and divide both sides by 2a. And so you get, you get x is equal to negative b over 2a. And so that's the x part of the vertex. That's where the tangent is horizontal. And if you wanted to find the y part, you would just take this value and plug it in for x into your function. So I hope that makes you really happy. We just solved one of the mysteries of algebra, where we got this negative b over 2a from, and so I hope you're excited about that. We'll do a few more examples. This video is getting a little long, so let's stop this here, and I'll see you in the next part.